Hey everyone, looking at this question, we have a hypothesis testing question, and we're going to use a interval method to solve. Because we have a unknown, x bar, that we need to find the range of values for. So an owner of a small factory uses a machine to dispense milk into bottles. The volume of milk dispensed is assumed to be a normal variable with standard deviation 8.5 milliliters. A random sample of 100 bottles of milk is chosen and a test is carried out at the 5% significant level. So 100 bottles, 5% SL. Then basically your hypothesis is to whether if it's less than 750 ml, then find the ratio value of x bar. So, and well, where the hypothesis would be rejected. So now what test are we testing on is the left test, right? The left tail test, because we're now testing less than 750 ml, so which must be the left tail test, and we are testing it at the 5% significant level, so 0.05 is the area. And because the null hypothesis would be rejected, we are looking at this region down there. Alright, so obviously our hypothesis is H0 following mu equals to 750, and our second hypothesis is mu equal, or rather the first hypothesis would be mu less than 750. Now I'm not going to define the terms, like let mu and x bar be the volume of milk dispensed, or rather be the population and sample mean, blah blah blah. I won't be defining those. You kind of need to though, so take note. But since we have mu at 750, the idea is that the x bar must be within this region here, so we let this be A. Alright, and the idea is that we're gonna do standardization, because that's how, well, to obtain the p-value anyways. And that is the whole idea here, where after we standardize we get 0, and then same area 0.05, just that now our A becomes minus Z 0.05, which this equals to our A minus mu over sigma, right, after our standardization. Alright, so that is the whole idea behind using the interval method, and it's actually the same, right, as what we've done in the last video, in the original video of me explaining this method. Alright, so H0, H0, H1, then let's define the distribution of x bar. X bar follows 750, the same mean. Then we have the standard deviation 8.5 square, or rather standard deviation 8.5, the variance is 8.5 square, then divide by the sample, which is 100. Good numbers there, so it's easy for us. Now we have the test statistic, where it's basically under H0, or rather H0, we have the test statistic. It's a essay writing. To Z, or rather not, yeah, equals to Z equals to x bar minus mu, which is 750, over the standard deviation, which is now 8.5, over root 100, which is 8.5 over 10, and this itself follows normal 0, 1. Alright, standard normal distribution always follows mean 0, variance, or standard deviation equals to 1. Now, we then know that basically the rejection region is from minus Z 0.05, right? And we know that we got this value after standardization. So what we had was P x bar less than A is less than 0.05. Alright, so when it's less than 0.05, what happens? It's basically now going to take the same value at minus Z 0.05 after standardization. So essentially, what we're going to do is do what we've always been doing in this method, which is to simply consider the rejection interval, which is from this particular value onwards to, in this case, would be 0, right? It won't go to negative infinity because the volume cannot be negative. It can be 0, just that you can't dispense negative volume of water. So we just need to consider the interval, so rejection interval. So this is how I would present it. Alright, in fact, I won't actually even include this part because it's understandable, so I'm gonna erase that partially. Rejection interval would be 0 with the square bracket because we include 0, and well, using the formula mu minus standard deviation times the inverse norm. So mu is 750 minus, because we are looking at the left of the mean, then standard deviation in this case is 8.5 over 10. And then finally Z 0.05. All right. And this will give us a rejection interval of 0.748.60187444. Now the idea is that if your sample mean lies within this value, your hypothesis would be rejected, all right, at a 5% significance level. Okay, but if let's say your sample mean lies outside the rejection interval, let's say you have 749, then your null hypothesis would not be rejected. All right, so we do not reject H0. Okay, so the idea is, if you look at this graph again, the first graph that I drew, you notice that now at this point is 748.601. So anything less than that would definitely have a p-value less than 0.05. If there is a greater value, so let's say down here, you get a higher value than 0.05 and you will not reject H0. As such, we then need to simplify this rejection interval by, well, because we are dealing with an inaccurate number, it's time for us to convert it to 3SF, right? So non-exact number, non-exact answers. So how do we change it to 3SF? So usually we'll round up, right? We round up to 749. But as we have noticed, if the value of the sample mean is higher than 748.6, then you wouldn't reject H0. That means H0 would still stand. Instead, you need to round down. The rounded off range must be within the interval that you have placed in. You notice 748 is still the rejection interval, whereas 749 will be outside of the rejection interval. As such, the range of values, all right, you can't leave it as such. So the range of values is x bar between 0 and inclusive of 0 and 748. All right, so that's how we use the hypothesis interval. In fact, you don't need to really consider this. Right? All you need to know that x bar equals to mu, same thing, plus minus z 0. Or rather whatever probability, then sigma over root n. In fact, if you were to actually rearrange this as well, you notice that you can also do the same for mu. Mu equals to x bar plus minus z alpha sigma over root n as well. Because if you bring the plus over becomes minus, bring the minus over become plus, it's the same idea. Whether in this case for the mu, you take x bar as the sample mean, so whether is it leading to the left or the right of the sample mean. For x bar, because you're dealing with mu, you know, decide whether is it beside, left or right of the mean. Same idea for both. So that is the interval method for hypothesis testing.